Hey, I'm Ben, and today we're going to be talking about sigma notation. Now, if you haven't heard of or seen sigma notation before, it looks like this. It might look pretty intimidating, but it's actually very simple. Let's have a look at a dumbed-down version of sigma notation first. You might recognize something like this from elementary school. 1 by 1, 2 by 2, and finally, 3 by 3. Let's write a sigma notation for this pattern. First, you write the sigma. Now we can put n equals 1. At the top, 3. And finally, n squared. I encourage you to pause the video yourself to try to figure out what all these numbers mean. Did you figure it out? Let's go over it. First of all, n equals 1. This refers to where you start, so 1, and it gets plugged into the equation on the right. Let's plug in 1 to n squared. 1 squared equals 1. That gives you the result of this first bit in the pattern. N, that's 1 squared times 1 equals 1. Next, we increase n by 1, so now n equals 2. Plug it into the equation again. 2 squared equals 4. Next, we increase it by 1 again, n equals 3. 3 squared, that's 9. 3 times 3 equals 9. However, once we get to 3, we stop because the top number is 3. It increases by 1 from the starting variable every time. 1, 2, 3, till it gets to the top number, and it stops increasing. Now let's work on some example problems. How would you write a sigma notation for this pattern? 8 plus 10 plus 12 plus 24. I encourage you, yet again, to pause the video and try to figure out yourself. Could you figure it out? Let's write that sigma notation now. First, you're going to want to notice the pattern. Each time, it increases by 2. So we can infer that in the space of this dot dot dot, it increases by plus 2 enough times to get us to 24. So we can write plus 2 here. Now, at the bottom, let's just say we'll start with 8. Now, we can try this out. 8 plus 2, working so far. Increase by 1, 9 plus 2. That doesn't work. That's not 12, that's 11. So we're gonna have to rewrite our little equation on the right here. So let's try increasing by 2 however many steps we're on. So let's try 2n plus 2n. So that should work if we just make this 1. So 8, let's try 8 here. 8 plus 2 times 1. That is 10, but that skips the 8. So we can just instead make this 0. 8 plus 2 times 0, that's 8. 8 plus 2 times 1, that's 10. 8 plus 2 times 2, that's 12. Now we just need to figure out how to get to 24 with this equation. So let's try 8 plus 2 times something, right? So 24 minus 8, that's 16. 16 divided by 2, that's 8. So just 8 plus 2 times 8, that's the number we can put on the top. And 8 plus 2 times 8, that's 24. So this is a successful sigma notation to write for this particular pattern. One important thing to note is that sigma notation is also sum. So when you get all these answers, you have to add them up too. For example, this first problem. This problem equals 14 because 1 squared plus 2 squared plus 3 squared is equivalent to 1 plus 4 plus 9, which is 14. So that's just a really important thing you need to know. And that's why this pattern as well is 8 plus 10 plus 12 and not 8 comma 10 comma 12. That's why you add, because sigma notation always represents a sum of some sort. Now let's try one last example problem together. This one might be a bit harder, so get ready. How can we write the sigma notation of 1 plus 4 plus 9 and then plus 25? Remember, before we continue, always try to solve the problems on your own. Did you do it? Let's go through the solution. If you can figure out, that's okay. And if you did, great job. Now, there are multiple ways to solve this problem, but I'll just go for one. What 1, 4, 9, and 25, they all have in common, they're perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 5 squared is 25. So let's start writing the sigma notation down. We see that it's n squared, 1, 2, 3, and then we end at 5, and on the bottom, n can equal 1. Let's just make sure, check that it works. So n is 1, 1 squared, that's 1, we're good. N equals 2, 2 squared, that's 4. N equals 3, 3 squared, that's 9. N equals 4, it's not in there, but we can just assume it is. N equals 5, 5 squared, 25. So this works perfectly. And that's it. That's the basics of sigma notation. I hope you learned something new today, and thank you for watching.